presentation will have Dr. Matas.
Thank you, Mr. Chairman. Dear gentlemen, my name is Richard Matas. I'm from New Technology Research Center and from also from Faculty of Mechanical Engineering, Department of Power System Engineering. My presentation is a bit a mistake, yes, because I am not the main author. The main author of the presentation and of the work is my graduate student Jakub Kazda, but he works in a new job now, and also I have to present his work. And the second mistake is that this presentation is not about power system, but I think that the presentation could be interesting for you. Also, here you can see the outline of my presentation, and you can maybe see or hear some word about it. So, a few words about introduction to the problem. The study was focused on PIR detectors, passive infrared detectors. They are devices working on the pyroelectric principle for protection and security against damage or theft. You know these detectors, I think. They are in all big buildings now. The principle is that the pyro the pyro element evaluates a change of infrared radiation of the objects, and the change leads to a change of value of the output voltage, and if necessary, an alarm is triggered. These detectors are standardly tested according to European norm, and it's testing in standard conditions, and mostly it's no problem to make this test for detectors of manufacturers. But the sensors may be exposed to conditions that are not standard, are other from this specific prescriptions, such as placement near windows, near various heat sources, fans, air conditioners, or above heating elements in the floor. And the goal of the project was to explore the potential of CFD simulations to identify the impact of such non-standard or of design conditions on PIR sensors. Here you can see the geometry of two selected sensors, type 1 and type 2. The model was built including the volume of the PIR body for considering of the heat accumulation in transient simulations, but it was simplified. And the computational domain around the detector was determined by the dimensions of the specific test cabinet from one European country. It was a test that doesn't directly comply with norm standards. And in this cabinet are stricter conditions for sensor testing, and it can be in some cases a problem for the detectors, and it's and their function or reactions. The heated air flow enters here through an elbow and outlet nozzle to a pad with a test detector. Place it here on the wall. Firstly, was made a mesh-independent study for steady incompressible flow. The COD system was used ANSYS Fluent, and the as turbulent model was chosen. The industrial standard is a sticky omega model. The inlet air temperature was 35 degrees and the inlet flow velocity 0.5 meters per second. Here you can see the picture with surfaces for evaluating of the results for mesh study and for the simulations also. For the mesh independent study was created 9 mesh versions of the type 1 model of detector, and mean values and RMS fluctuation of velocity magnitudes and temperatures were monitored at specific surfaces for stationary simulations. Sorry. Here you can see the results of mean temperatures and fluctuations for and here for mean velocity magnitudes and their fluctuations. And you can see that for finer meshes are the results very similar. Also, the 6th version of the mesh was chosen as the, you can see the applicable discretization level, and it was such a polyhedral mesh with about 8.7 million polyhedral cells with finer domain around the detector and coarser domain in the surround. And the same mesh generation settings was implemented also on the type 2 PRR model. And these 2 meshes were used for the transient simulations. For the transient simulations was monitored the important or selected quantities in selected planes and points. You can see here in the pictures. The running of the simulation was first as stationary, and then was run additional 30 time steps, and the evolution was carried out during an additional 300 steps with the time step 0.05 seconds. All results were evaluated relatively, although you can see not the temperatures and velocities in absolutely values, but all values are normalized by the maximal value from the stationary simulation of the type 1 of the type 1 detector or type 1 model. Here you can see the instantaneous values of relatively temperatures and relative velocities. Here is the type 1, type 2, and for temperature fields, and here you can see the velocity fields around the detectors. The heat propagation caused by flow along the wall and around the detector. The effect this fields can affect the function of the sensors. Here you can see also the separation of flow in front of the lens. Here is the lens of the detectors. The results also shown that the flow before or in the part behind the nozzle is not stable, and how to say, I think it's splitting or unstable or not a good determinant. And also the test cabinet and especially airflow from the supply pipe here is not satisfactory for the good or to say independent testing. Yes. The fluctuations monitoring here shows that the type sensor or flow error and velocities and temperatures in the type 2 sensor cause higher fluctuations compared to the type 1. Based on results, was proposed a new test cabinet design. You can see here the new design of the cabinet. The design should guarantee homogeneous flow at the outlet of the pipe here, a variable sensor positioning in this part, and changing and control of the flow pattern at the outlet of the supply pipe with custom-made elements placed here in the outlet from the pipe behind the heater and fan. Also, conclusions. The pilot study shown that the CFD modeling can be useful in the design and testing of PIR detectors. It was prepared a methodology for CFD simulation of fluid flow and heat transfer around these detectors in design conditions. Obtained result can help the manufacturer and users to address the placement of the sensor for various conditions. The results also show also the importance of the shape of the sensor with respect to the interaction with the flowing of the warmed air. And last but not least, the new design of the original test enclosure was proposed for testing sensor in non-standard conditions, eliminating the problems of the original one. I think it's all from me. Thank you for your attention.
Can you tell us for which purposes?
For which?
For future. For which purpose is this instrument determined?
The PIR detector, or
yes, yes.
It's a detector for detection of persons in a room or in a space, and the conditions are very important for the function of the detector.
And price of this instrument?
The price is not so high. It's a standard sensor. They are produced in millions pieces, but in some cases are problems with these conditions.
Okay, thank you. Your questions? Notes? So we
Thank
will
you.
continue with next.